Good evening, Internet. I am Matt Buyak, and in this video, we'll take a look at the 21st problem from the Project Euler problem archive. So this problem asks us to find the sum of all amicable numbers under 10,000. It gives, as an example, the numbers 220 and 284. And we consider these to be amicable numbers because the sum of the divisors of 220 is 284 and vice versa. Now you'll notice that this problem is asking us to only find the amicable numbers up to 10,000, which isn't particularly large. And so we really don't need to do anything too sophisticated to solve this. We can pretty much just brute force it. So let's get into it. As usual, we'll copy our problem directory, or excuse me, our template directory to make our problem directory. And open our main.cpp. OK, we'll probably want a little helper function here to find the sum of divisors. And as I said, we're really just going to brute force this. And so we'll have an index. Actually, we'll call it div. That'll be the divisor we're currently considering. And we'll have sum, which is the sum thus far. OK, so we'll say for div is equal to 1, div is less than n, increment div, and if n mod div is equal to 0, then sum plus equals div. OK, and return sum. So then down here, we'll want to consider each number from 2 to 9,999. You could consider 1, but it has 0 divisors, and so we don't need to. We will need an index. We'll need a sum starting at 0. Let's we'll say ds. That's going to be the sum of divisors for our current integer. And then we'll just increment from for I is equal to 2 less than 10,000. That is 10,000 increment. OK, so we'll say ds equals sum of divisors of I. And then we want to be careful not to double count our amicable pairs. That is, if we, for example, with 220 and 284, we don't want to get to 220, find that 284 is a matching pair or matching partner, and then also at 284, find that 220 is a matching partner. We only want to count each pair once. And so let's say if ds is less than I, and sum of divisors of ds is equal to I, then we'll say found pair. And then we'll say sum add ds add I. and then just print the sum. Okay, so we see our expected 220, 284 as the first pair that's listed there. And you see our answer given as 31,626. So if we go over here and we check, you can see that that does indeed match our expectations. So that was a pretty quick and easy solve. However, I want to do a quick experiment here. If we go back over to our problem, and let's suppose that this was 100,000 instead of 10,000. So we run it, and we're going, and we're still going, and that's going to go for a little while. And so you can imagine that for problems asking for divisors of larger numbers, we might need some more sophisticated approach. You can see it did eventually come up with a solution there. In particular, I pulled up this problem here. Problem number 95 asks a very similar question involving amicable chains, which are defined similarly to amicable pairs, but it asks about numbers up to 1 million. And you can imagine that this took, I don't know, 15, 20 seconds. 1 million could potentially take much longer. And so we're going to need some more sophisticated tools to handle these kinds of problems, especially because they're so common. Problems involving finding divisors, finding the sums of divisors, finding the number of divisors. And so that's going to be the subject of the next video. We're going to add some code to our number theory library that will help us in dealing with these kinds of problems. So if that sounds interesting to you, then look out for that. If that doesn't sound interesting to you, then the next problem will be problem number 22.